In chemistry, the molar concentration is defined as the amount of a constituent divided by the volume of the mixture. It is also called molarity, amount of substance concentration, amount concentration, substance concentration, or simply concentration. The volume in the definition refers to the volume of the solution, not the volume of the solvent. 1 liter of a solution usually contains either slightly more or slightly less than 1 liter of solvent because the process of dissolution causes volume of liquid to increase or decrease. The reciprocal quantity represents the dilution which can appear in Ostwald's law of dilution. Notation: in addition to the notation there is a notation using brackets and the formula of a compound like A. This notation is encountered especially in equilibrium constants and reaction quotients. Units: the SI unit is mol per meter 3. However, more commonly the unit mol per liter is used. A solution of concentration 1 mol per liter is also denoted as 1 molar. 1 mol per liter equals 1 mol per decimeter 3 equals 1 moldmer 3 equals 1 meter equals 1000 moles per meter 3. An SI prefix is often used to denote concentrations. Commonly used units are listed in the table hereafter. Related quantities, number concentration. The conversion to number concentration is given by where is the Avogadro constant, approximately 6.022 A, 1023 molar 1. Mass concentration. The conversion to mass concentration is given by where is the molar mass of constituent. Mole fraction. The conversion to mole fraction is given by where is the average molar mass of the solution, is the density of the solution and J is the index of other solutes. A simpler relation can be obtained by considering the total molar concentration, namely the sum of molar concentrations of all the components of the mixture. Mass fraction. The conversion to mass fraction is given by molarity. The conversion to molarity is where the solute is assigned a subscript 2. For solutions with more than one solute, the conversion is properties. Sum of molar concentrations a normalizing relation. The sum of molar concentrations gives the total molar concentration, namely the density of the mixture divided by the molar mass of the mixture, or by another name the reciprocal of the molar volume of the mixture. In an ionic solution, ionic strength is proportional to the sum of molar concentration of salts. Sum of products molar concentrations partial molar volumes, the sum of products between these quantities equals 1. Dependence on volume. Molar concentration depends on the variation of the volume of the solution due mainly to thermal expansion. On small intervals of temperature the dependence is a. Where is the molar concentration at a reference temperature, is the thermal expansion coefficient of the mixture. Spatial variation and diffusion. Molar and mass concentration have different values in space where diffusion happens. Examples: Example 1, consider 11.6 Ag of NaCl dissolved in 100 Ag of water. The final mass concentration will be, NaCl, equals 11.6 G equals 0.104 grams per gram equals 10.4%. The density of such a solution is 1.07 a gram per milliliter. Thus its volume will be, equals 104.3 milliliters. The molar concentration of NaCl in the solution is therefore, NaCl, equals 104.3 milliliters equals 0.00192 moles per milliliter equals 1.92 moles per liter. Here, 58 gram per mole is the molar mass of NaCl. Example 2. Another typical task in chemistry is the preparation of 100 ml of a 2 mol per liter solution of NaCl in water. The mass of salt needed is, NaCl, equals 2 moles per liter 0.1 L 58 grams per mole equals 11.6 G. To create the solution, 11.6 G NaCl are placed in a volumetric flask, dissolved in some water, then followed by the addition of more water until the total volume reaches 100 ml. Example 3, the density of water is approximately 1000 grams per liter and its molar mass is 18.02 grams per mole. Therefore, the molar concentration of water is H2O, equals 1000 grams per litre / equals 55.5 moles per litre. Likewise, the concentration of solid hydrogen is H2 equals 88 grams per litre / equals 43.7 moles per litre. The concentration of pure osmium tetroxide is OZO4 equals 5.1 kilograms per litre / equals 20.1 moles per litre. Example 4, a typical protein in bacteria, such as E. coli, may have about 60 copies, and the volume of a bacterium is about L. Thus, the number concentration is equals 60 / equals 6A, 1016 La1, the molar concentration is equals 6A, 1016 La1 / equals 10 moles per litre equals 100 ml. If the concentration refers to original chemical formula in solution, the molar concentration is sometimes called formal concentration. For example, if a sodium carbonate solution has a formal concentration of equals 1 mol per litre, the molar concentrations are equals 2 mol per litre and equals 1 mol per litre because the salt dissociates into these ions. References. External links: Molar solution concentration calculator, experiment to determine the molar concentration of vinegar by titration.